Hi, welcome to In and Around Computer. In this video, we are going to see what is paging in operating system and how does it work, and also the paging techniques. First, we can see the paging glossary, and first with the pages, that is pages or fixed size blocks of logical or the secondary memory, and the pages represent a unit of information transfer between the main memory and the secondary storage. And a page set is a process working set, and a working set constantly changes as the process accesses different parts of memory. So, and what is page table? It's a data structure that enables the memory management unit to translate the logical address into physical address. And we have a separate video on this logical and physical address. You can check that also. And physical memory. What does it mean by this physical memory? The actual memory available to the computer in the form of RAM. So that is what a physical memory means. And in paging, the physical or main memory splits into fixed size blocks or page frames, each with a unique address. The frames are the same size as the pages used by the process. And what is a virtual memory or logical or secondary memory? This is a hard disk or solid state drive that serves as an extension of the main memory. That is, it compensates for the physical memory shortages by temporarily bringing in data from the RAM. So this logical memory is divided into same size blocks called pages. So this is what is meant by pages, and each page has a logical address within the virtual memory. And so this is about the pages in the virtual memory. And another set of terms, that is memory management unit. This is a hardware component that translates the logical address into physical address, and this also manages the allocation and deallocation of pages in memory. And logical address or the virtual address, that is when a program runs, the CPU generates a logical address for each page. So then the IMMU translates the logical into physical address that should be done. So and what is meant by logical address space? That is a set of logical address generated by running a program. And physical address, each frame within a physical memory has a unique physical address, and the address is represent a specific location of process in actual memory. So address which represent the specific location actually is this is termed as the physical address. And physical address space, the range of all possible physical addresses a system is able to reference. So these are all the terms which will be used in the paging, and make a note of it. And now we can move into what is paging in OS. So this the paging enables an OS to transfer data between the secondary or we can say it as the virtual memory and the primary memory. So the transfer that has to be done during the execution of processes. That is, it moves the data from paging enables the data transfer between the secondary and the primary memory. And both storage types, or that is both storage types, that is in main memory and the virtual memory, all are divided into fixed size blocks. And whenever a program executes, it splits into pages that we can see in the diagram, and the OS automatically stores them in the secondary memory. So whenever a program executes, it splits into pages. And when the process requests the memory, the OS allocates page frames from the primary memory to the process. So this is what is done with the help of paging. And now, now we can see next what happens. Then OS moves the program pages from the secondary memory to the primary memory frames that we already said. The program pages will be in the secondary memory, and next when the program executes that is the processes are divided into pages that we already said, and then the OS moves the program pages from the secondary memory to the primary memory frames. And notice that the pages of the process are only brought in this primary memory when they are needed, otherwise they will stay in the secondary storage. And the physical that is the logical pages and the physical page frames maintain the relationship using a structure called page table that we already said, and the MMU then uses the page table to translate the logical address into the actual physical addresses. Now we can see the paging workflow. That is, this paging workflow ends in a page hit or a page fault. Now we can see the scenario where it ends in the page hit. First, a process executes. The OS allocates the process segments into same sized pages in the virtual memory. It also creates corresponding page frames in the physical memory, and this is shown in the diagram. And the OS creates a page table which maps the process logical pages to the physical page frames. And this is the third step, and another process requests access to the process frame or page. Now the requested page, if it is already in the main memory, the process continues execution, creating a page hit. So this gains access to the physical memory. So this is a page hit. And another scenario where it will be a page fault. That is, if the requested page is not in the main memory, the system is dealing with a page fault or page miss. So the paging process continues to resolve the issue. That is, the MMU uses the page table to identify the process's correct location in the physical memory or main memory. So the page table updates with the correct physical address, and the OS brings the particular page into the page frames in the physical primary memory, and thereby the process resumes from the point of interruption and can now access the page. So now the page fault is resolved. So this is the scenario when there occurs a page fault or page miss, and the MMU resolves this particular issue, and by mapping the using the page table and identifying the correct location in the main memory, and brings the frames into the primary memory, and the process resumes from the point of interruption and can now access the page. So this is what the paging workflow follows. And now we can move to the paging techniques. And the a paging implementation offers multiple methods, and a choice of specific technique depends on several factors like the OS type, available memory, and the process requirements. For example, this demand paging is a good choice for OS that need to be efficient. On the other hand, anticipatory paging is also better choice for OS that needs to be responsive. So now we can see the various techniques in paging, and first we can see What is demand paging? The most common memory management technique in modern OS like Windows, Linux, and Mac OS. And this optimizes the memory usage by keeping only the currently used page in memory. And anticipatory paging, that is a more aggressive form of this demand paging that preloads the pages near the requested page as soon as possible. The goal is to reduce the page faults and latency by predicting which pages are not in RAM pages not in RAM are likely to be needed soon. And next technique is pre-paging. This is a less aggressive form of this anticipatory paging. The system preloads any pages that might be needed in the near future but not immediately soon. And next technique is free page queue stealing and reclamation. These techniques manage the memory by keeping track of free frames and reallocating the frames as needed. So this will be of three techniques, that is free page queue, page stealing, and reclamation. And then pre-cleaning and copy on write paging. These we can see the techniques, that is pre-cleaning means the process saves the contents of the modified pages back to disk even if those pages are likely to be modified again soon. So when the new program runs, the system does not have to wait for the pages to be read from disk, which improves the startup time. And copy on write paging, when a process attempts to write a page that is already in use by another process, the OS creates a copy of the page and gives the process exclusive access to the copy. So this ensures that two processes cannot overwrite each other's data. So this is one of the technique. And next technique is the segmented paging and the inverted paging. And this segmented paging combines paging with segmentation by splitting the main memory into variable size segments. Segmentation is a separate concept that we can see in another video, and each with a page table. The segments divide into even smaller fixed size pages. Unlike virtual memory, which employs the page-based division, the segments handle the mapping of virtual to physical memory addresses. And inverted paging, that is a technique where the page table is in memory and the physical memory is divided into frames. When a process needs to access a page, it looks up the page table to find the physical frame. So subscribe to my channel if you feel contented.